Okay, hooray. It's the series sequence chapter that is only has one formula. And yet these you would think these would be the hardest kind of problems because you're finding the sums of infinite series. That's kind of a mind-bending idea. Most infinite series you cannot find the sum of, right? 1 plus 2 plus 4 plus 8 plus dot dot dot. You can't find the sum of that. It's dot dot dot. It's infinity. And even if you're getting smaller, 5 plus 4 plus 3 plus 2, dot, 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 you're not going to find the sum of that because this series is arithmetic. It goes on to -1, -2, -3, -4, and it's going to equal negative infinity. But if it's geometric, sorry, and you can't circle on the note, then, and it's infinite, there are some series that actually you can find a sum of. Not this one. This is geometric, but some. Which ones? The ones where r is less than 1. Now, that's not always going to work. Like this series, I cannot find a sum of. 1 plus -2 plus 4 plus -8. Now in that series, r is less than 1. Sorry, technical problem. In that series, r is less than 1, but I cannot find the sum because you can see this swings so wildly and predictably. Yeah, there's positive and negative. You could think they might cancel each other out, but no, because it's getting bigger and bigger and bigger, it doesn't converge on one sum. So r not only has to be less than 1, r has to be bigger than -1. In other words, r has to be between 1 and -1. And those are the kind of series, these are the kind of series we can find the sum of. Only if r is between 1 and -1. So an example might be this: 8 plus 4 plus 2 plus 1 plus 1/2 dot dot dot. All right, this is gonna, because I'm adding, what I'm adding is getting closer and closer to 0. That's why I can find a sum of it. And the formula is the sum of an infinite series. Sum of an infinite series. I just made up that notation. You don't necessarily need it. The sum for this section is the first term divided by 1 minus the common ratio. All right, so first step is find the common ratio. So what are we multiplying by here? 1/2. So in this case, r is 1/2. I need to check, is that between 1 and -1? Yep. All right, so then the sum is the first term, 8, divided by 1 minus 1/2. What is 1 minus 1/2? 1 minus 1/2 is 1/2. So that equals 8 over 1/2. To divide by a fraction, I multiply by its reciprocal. So this is 8 times 2, which is 16. So this infinite sum is 16. And you can sort of see it. 8, 12, 14, 15, 15 and a half, 15 and 3/4, 15 and 7/8. Getting closer and closer to 16, but it will never reach 16. So that's the infinite sum of that sequence. One more. 50, yeah, let's go, yeah, 54 plus 18 plus 6 plus 2 plus dot, dot, dot. What's the common ratio? We ask that first because we need to know, can we do it? What am I multiplying by? Well, I'm dividing by 3, so I'm multiplying by 1 over 3. So the common ratio is 1/3. Okay, my sum of the series is the first term, 54, divided by 1 minus the ratio, 1/3. Well, that equals 54 over 2/3. And that equals 54 times 3 over 2. And if I do punch it out of the calculator, do the math, I'll find out that this is actually equal to 81, and that is my answer. And we can check it. 54 plus 18 is 72, plus 6 is 78, plus 2 is 80. The next term will be 1/3 of 2, which is 2/3, so it's 80 and 2/3. We're getting closer and closer to 81, but we're never going to pass it. The end.